it looks like this. So it looks like an upside down U, and so the bars bend. There's a curve there, the curve on that one. The bars bend down on the footing, but it's a bit of an example of a PDF file of what one student sent in. It's not perfect, but it's a pretty good drawing. And there's a few notes. I showed you this in the lecture. But that's the sort of thing that you need to do. I suggest you do them in different colours. The layers they used were relative to, I think that one was like called whatever that is, 120, whatever it is. So it was 1203, and the layer would be called 1203. It's 1204 or something. It would be called 1204. I want you all to put a layer called cover. So offset this by whatever the cover is, so that I can turn that layer on and see that none of your bars go past the cover. It's only an example. It's not, it was 216 or 17 or something, that particular drawing. I've also got something else which is a bit of a treat, which I haven't done in the past, which is this one here. I think that's okay. Now this here is an example in AutoCAD. I don't want anyone using this drawing as their own, but I'm happy for you to have a good look at it and see what I've done. There's a class example here of example 2, exercise 2. I'm not going over this one, sorry. The answer to it is here as well, and it is a work exercise that you can work your way through and work out the logic behind it. So here's the question, and this was also an exam question as well. In this case, the length of the bars is limited to 9 meters, and the length of the structure is 9 meters as well, I think. What is the length of the structure? Overall length, oh no, the length of the structure is 9 meters. The bars are 10 and 12. So that is what we call a water race, which means it goes on and on and on with water coming into it. And I've given you, if you have a look at that, I've given you a way of working out all the quantities for that, and then going through and working out each bar length. See here, this person has drawn the number and then worked out the overall length. And there's some good sketches there to show you how it's done. Notice it sketches exactly where the bar starts from here. Exactly what I was trying to tell you guys before. And how we put it into a bar schedule, just like I've done behind me. You can put STR if you don't want to write the word straight. You can put STR on top of a line as well. Notice they've put the total weight there as well. So, if you look at this structure here, which is on a slight lean, and we go back to my AutoCAD drawing, you'll see that I've drawn it up there. And when you look at some of it like this, it goes in behind that bar. I've used donuts to draw it up. And if you have a look in plan view, which is what you guys are going to have to do, you'll notice how I've drawn it. The number of bars, the bar mark, the spacing. Now that spacing is always the 300 or 200 or whatever the engineer says at the time. Don't make the spacing like 289 or 246.2 or something, whatever you work it out on the calculator. It's actually the spacing of the bar at the time. You'll notice down the bottom here, I've put the donuts Now those donuts are not exactly the right spacing, but they are exactly the right spacing according to when I got my calculator out and worked it. It's actually 256. Here we are. Should have been 250, but it worked out at 256. So what I don't want you to do is do the spacing all the way along and end up with a different spacing at the end. It needs to be worked out exactly. Okay. Now a lot of students like to draw it up in elevation first and then project it onto a plan view. There's my plan view. You can see the circles are approximately 2 times the diameter of the bar, and that's roughly what size the delimitator bar should be. I will let you away with a little bit smaller than that, or a little bit longer than that, but not much longer or smaller. Okay? Delimitator bar. That's how we do a lap. You're allowed to have a little gap if you want to. And you'll notice that this yellow bar here, see the yellow bar? It bends. See how it goes down and up? It's a U-bar. You haven't got a U-bar, but you have got one that bends downwards. So looking at it from plan view, it's going to look like this. Now if I was to offset the cover, I think it's 40. That's what it looks like. This is my donut. Can you all see that? So, the first thing is, the bar only comes to halfway along the diameter of the donut. Don't take it all the way to there, or it's drawn wrong. And secondly, the donut touches exactly on the cover. That donut should be circular. I have to do a regen. If I type regen, it'll turn out to be circular. R-E-G-E-N. Yeah. Now, a filled donut means that the bar goes down or up. So that's why we always show 2 views. Because when you have a look at this view down here, all of a sudden it becomes very clear that this bar goes upwards and that you're looking down on it. But if it went the other way, we wouldn't have it, we can't tell just from a plan view. I only want you to do a plan, and I only want you to set it out the same way that this example is. I haven't completed this, the yellow bar hasn't got any text on top of it. And you're a little bit different because you've got a lap. Your bar lap, this one doesn't lap. So if your bar laps, one thing you've got to be very careful of, and I'm only going to say this once. If you look at this example, if you're drawing it and your bar laps, right, then if there's 36 bars on your schedule, it's going to be 18 on that one and 18 on that one when you call it up on your plan view, all right? Don't put 36 and 36 like a lot of students do, and don't put 18 on here and 18, 18, which it should be 18, 18 and 36 on the bar schedule, right? So the bar schedule will give your totals only. A lot of students think, oh well, I better split it up for Roger, so they do 2 1603s. One's 18, one's 18. That's wrong. That's completely wrong. Although you think it's right, it's wrong. Plus the poor Steely, he's sitting there, he does it all out the door. Oh no, there's another lot of 1603s, I didn't see those. The other thing is, students often don't put these in order because they work out, the 1602 might be the easiest one to work out, so they work that one out first. Then they do 1604, then 1603, and then maybe last 1201. In your head you can do that, but not on paper. The bar marks should flow nicely from 1 down to wherever, okay? Because when they're looking at the drawing of this, now you're doing a very simple drawing, believe me. I've done multi-story buildings, and the bar marks start from the bottom up. So when you get to about story number 60 or something, your bar marks might be up to 1,000. and you're not looking for bar mark 1 when it comes to the 60th story. So when they go to site, they get delivered, and everybody knows that's the bottom floor, the next floor, and so on. So your bar marks should always on the schedule be in consecutive order. So you might do it all right, and you get marks deducted for not having that consecutive. Right? This is one of the easiest things for me to mark. If those totals aren't right, 0, 0, 0, 0, 0, okay? So I really expect you to do it precisely. It's not quite that bad. I do tend to give a couple of marks just for trying, but it kind of annoys me because really you should be getting it right rather than, a little bit right. Decimal places, I often get asked that. 2 decimal places is fine, and 2 decimal places in the answer is fine as well. But you should be doing your dimensions, these ones, to 3 decimal places, all of these, and then you can round off to 2 here and 2 at the bottom. If you ended up getting 503.02 because you've rounded off a little bit wrong, you're likely still to get full marks with me. Okay? But if that ends up being 76 or something, that's way out. It's way out on the calculations. I don't need to see your calculations, I just need to see the answers. So already some of you are starting to say, well, I know how to get the answers for this one, it's very simple. Hey bro, or bro S, what did you get? Thanks very much. And the answer goes in, right? And if it's right, how do I know? I don't, do I? It's just a number. I can't say you cheated. If it's wrong, it's going to look really awkward because it'll be the only 2 students with the wrong answer. But I pick you up in the test. There will be at least 4 questions in the test on reinforcing, and that is worth 5 marks. So if you cheat that, you've pretty much lost 4 marks in the test, okay? So you do need to get your head around this, and it's the same with the quantities as well. I don't know, when I was studying, the way we did it was we did it ourselves, and then we had a big fight with our friends to see who was right. And at the end you learned off that. When it came to exam time, it was easy because we'd already had a good argument over how to do it the correct way. But I guess everybody's different in the way they study these days, so it's up to you. So we have got about 3 weeks to get this in, about the 20th or 21st or something. But it'll come up quickly. It's 2 weeks on Sunday. So it's a good idea to progress it a little bit more. Next week we have structural steel lecture, not as long, but we have another one of these things to do for steel, which will help you with your assignment. Okay, so you don't have to do that steel bit yet on the quantities, but you can do at least 10 marks out of 15 if you wanted to progress a little bit further. Also, if you bring your assignment in to class next week, there's a chance that you can ask some questions on the way you've laid it out or something like that. Okay?